All right, good day, good afternoon. We are going to do the last section in chapter 3, 3.6, graph and linear inequalities in two variables, which we did in class today. All right, so just like the lecture, basically, I'm going to go over, but this time I'm going to start with page 257 and work my way through the examples until we get to the end. So hopefully by then you'll have a great idea what's going on for you to be successful for this portion of the exam, which will happen on Wednesday. All right, so let's start right now. Determine whether each ordered pair is a solution of the inequality 2x minus y is less than 6. So we're just going to do some plugging in and make that determination. All right, so this is going to be, remember, x and y. 5 is the x, negative 1 is the y. So it's going to be 2 times 5 minus negative 1 for the y. Okay, is less than 6. So here I've got 10. 2 times 5 is 10. Plus 1 is less than 6. 11 less than 6. Nope, this is false. For B, x is 2, y is 7. It's going to be 2 times 2 for x minus 7. Is that less than 6? 4 minus 7 is less than 6. Negative 3 is less than 6. This is true. Okay, don't be fooled looking for that one number versus another. It can be something that resonates as true, and that's what we're looking for here. And it definitely indeed is. Negative 3 is less than 6. Okay, next problem. Okay, I'm going to go by the book and I'll start off this problem with this inequality as it is, that I'm going to change the inequality to an equal sign. So it'll say x plus y equals 7. And that way I can graph this how I'm accustomed to using the equal sign. So that's my objective here, is to graph this line. All right, if we subtract x from both sides, I can use the slope-intercept method to graph this. So it's going to be y equals negative x plus 7. Okay, let's go ahead and graph this. I'm going to start my y-intercept at 7. 1, 2, 3, 4, 5, 6, 7. My slope is negative 1 over 1. Negative 1 over 1. Rise over the run. So I'm going to go down 1 and over to the right 1. There's my second point. Grab a straight line. Something like this here. And bring it up. And let's see what the behavior of this graph will be. So now I want to pick that. Point, test point. I'm encouraging us to use the 0, 0, right? And when I do, does that satisfy the original inequality? So that would be, if x and y are both 0, 0 is less than 7. So that is true, and it's going to be all the values that are below the line. including the 0.00. Okay, one other thing, my line here should be dashed. So I am going to dash it. I don't have a mechanism to give me a dash line, but I will dash it this way. Okay, so make sure you have a dash line here. That's not a bad way to do it. Okay, there's my dash line. And then I want to try the bucket like you have in my math lab. See if I can fill that in with something. Oh, I guess it doesn't quite behave like yours does on my math lab. Okay, so let's go out of here and I will just scribble it in like I was doing that in class. Okay, so here it is. Get my pencil back. Maybe a brush. Do I have a big brush? I don't know. Try that. Nope. How about an eraser? Oh, nope. How about the pencil? Like I was doing it before. So I'm going to do it here. Scribble it in here. This is all the shaded part. Below the line. Alright, you get the idea. Okay. So that is done. Okay, here's another one. Same idea here. I'm going to rewrite this with the equal sign. Let's keep in mind this inequality here is telling us we're going to use the solid line. So I'm going to have 2x minus y greater than or equal to 3, which I just said I was going to replace this with the equal sign. There we go. And graph this equation. So let's see, how about I subtract 2x from both sides. Divide everything by -1. And y equals, what is that? 2x minus 3. 2x minus 3. So I can go ahead and graph this now, starting with the y-intercept of -3. My slope is 2 over 1. So I'm going to rise 2 and run 1. There it is. I'll go back up to my inequality and see that it is a greater than or equal to, so I'm going to use a solid line. Let's use that solid line and graph this. Okay. Then I'm just going to use my test point of 0, 0 and plug it into the original equation here, or inequality. So again, that's going to be 0 minus 0 is 0. 0 is greater than or equal to 3. Is 0 greater than or equal to 3? No. So that is false for 0, 0. So my shaded area is going to be over on this side of the line. Okay. There we go. Next problem. Okay, here's example 4. Oh, let's see. How about I change this now to read x equals 2y. And this time I think it's easier to use a t-chart for a couple points by giving y two values. When y, for example, is 0. When y is 0, then x is 0. How about when y is 1? When y is 1, x is 2. Okay, now I'll plot the point to be 0, 0 and 2, 1 over 2 up 1. My inequality, to help me determine what my line is going to be made of, it's going to be a dashed line for the inequality greater than. Alright, so with that, I'm still going to use this line, and I'll tell you why, it's to keep it straight. The other way, it may not be so straight. So, I'll try it like this. And then I'm going to make it a dash line. Let's see if I can do something like that. Ooh. Is that dashed? Not quite. I'll go back to the red. And oh, that's a new one. That's a dash line. Okay, let's see if I can get rid of that. Put some white there, but the whole thing's changing. I'm not used to that happening. No, it did. Anyway, I'm going to pick a new point on this line. I know that's the dashed line here. And I'm going to take a test point of over right here. I like using 2, 0. This is 3, 0 for my test point to the original expression here. Alright, so that means coming down here when x is 3, is that greater than 2 times y, and y is 0. So 3 is greater than 0. True. Alright, so that means all this region underneath the line is what we were looking for. Okay. Very good. Next. All right, next problem is this. All right, just so you know the alternatives we have in problems, this looks like a nice one to set up the t-chart and do the x-y intercepts with. Why? Because the x and y are on the same side as the inequality. And 5 goes into 20, and so does 4. So I'm going to get some nice whole numbers here. So let's see. When x is 0, y is going to be 5. When y is 0, x is going to be 4. When I plot it, 0, 5, 1, 2, 3, 4, 5, and 4, 0, are here. I got the inequality with the equal sign, so that means it's going to be a solid line. And there's my solid line. Now I'm going to pick my test point here, and my test point is going to be the origin again. 0, 0, and I can look at this and say when 0 plus 0 is less than or equal to 20, which this changes to be 0, is less than or equal to 20. And that, of course, is true. 0 is less than 20. So we know to shade in all this area here. Okay-doke. Next problem. That was example 5. All right, example 7. I'm skipping example 6 because it's of the variety y equals a number. And you know that is a horizontal line. X equals a number is a vertical line, etc. So I'm skipping that one. I go to right to number example 7. Again, let's graph this. Oh, I don't need an equal sign. I need a less than or equal to. So I'll make this less than. Less than or equal to. Let's do that. All right, graphing this to slope-intercept form. -4 is down here. 1, 2, 3, 4. My slope is 2 over 3, so I'm going to rise 2 and run 3. Okay, now I'm going to attach a solid line because of the inequality equal to. Just go ahead and do it this way. Okay, take our test point of 0, 0 here and plug it in. 0 for the y is less than or equal to 2 over 3 times 0 minus 4. Okay, we know this is multiplied together. That's 0 times 2/3. So I'm going to end up with 0 is less than or equal to -4. 0 is less than -4, or is it? No, it is not. This is false. False statement. So we're not going to take the include the 0, 0 in our shading in portion. It's going to be over on the opposite side of the line because it was false. Okay, that's what all this means. Okay, that's it. I hope you get the hang of that. All right. End of today's 3.6.